Okay, so have you ever, like, walked outside in winter and just completely wiped out on, like, a pack of ice?
Oh, yeah, totally. Everyone's been there, I think. It's that, like, split second where you realize you have zero control.
It's the worst. You're just, like, flailing
Like
around.
a cartoon character, yeah.
Exactly. So today we're going deep, deep into the world of winter traction aids and how one company is using, like, serious science to prove theirs really
I
work.
love it. Science to the rescue.
Right, so we've got this fascinating case study, and, this company, they knew they couldn't just, like, say their product was good.
Yeah, especially when it comes to safety, people want proof.
Exactly. So they had to figure out, how do we stand out? How do we prove our product is legit?
Right, and they did it with this thing called ASTM 1894 coefficient of friction testing.
Okay, wait. ASTM-D 1894. That sounds kind of intimidating.
It's a mouthful, for sure, but it's actually not that complicated.
Okay, so break it down for me. What's coefficient of friction all about?
Okay, so imagine you're pushing like a big, heavy box across a rug.
Okay, got it.
Now imagine pushing that same box across a smooth floor. Way easier on the floor, right?
Yep, for sure.
That's because there's less friction between the box and the floor, and that's what the coefficient of friction measures. Basically, how much grip or resistance there is between two surfaces.
Got it. So higher friction means more grip.
Exactly.
Okay, so how did they use this test to actually, test traction aids? Like, what did they actually do?
So they didn't just like strap them to a shoe and start pushing. They got really specific with it. They tested three main movements: forward heel, backward forepart, and forward flat.
Okay, I think I can picture forward flat. That's just like regular walking, right?
Exactly. Yep. Just walking straight ahead. But forward heel and backward forepart, those get a little more interesting.
Yeah, those sound kind of tricky. Explain those a little more.
So think about walking uphill. That moment when your heel strikes the ground first, that's forward heel.
Ah, okay, I see.
And then backward forepart, think about like stepping off a curb, you kind of shift your weight back onto your toes for a second. That's the motion they were testing there.
Oh, I get it now. They're testing those, like, awkward in-between moments where you're more likely to lip.
Exactly. They're really trying to simulate like the real world ways people move on ice.
That makes sense. And get this, they actually did these tests on bare ice using shoes provided by actual customers.
Oh, wow. That's commitment to real world data right there.
Right. But it gets even more intense. They did 4 repetitions for each movement and even reconditioned the ice between each test. Like, why all that extra work?
So it all comes down to making sure the data is super reliable. Like you wouldn't want one fluke to throw off the entire experiment.
Yeah, that makes sense.
So by reconditioning the ice, they basically hit the reset button each time, making sure they're always starting with a consistent surface.
Okay, I see. So that's why they did it all so many times and reset everything. They wanted to be really sure about the results.
Exactly, because when it comes to safety, you can't be too careful, and the multiple repetitions that helps ensure the results are consistent and not just a random fluke.
I'm really starting to get how seriously they took this. And they didn't just test on ice, did they? The case study mentioned dry pavement setups too, right?
Yeah, they did, and that might seem strange at first, but think about it. In the winter, you're not always walking on pure ice.
Yeah, that's true. It's like a mix of everything. Some dry spots, some icy spots, and you never know what you're going to get.
Exactly. So testing on both dry pavement and ice gives you a much better idea of how the traction aids will perform in those like real life situations. Like you step off a bus onto clear pavement and then bam, there's a patch of ice around the corner.
Oh, totally. You're constantly switching between surfaces.
Yep. And they wanted to make sure their product could handle all of that.
Okay, so they did all this crazy testing, got all this data. Did it actually, prove anything?
Oh, absolutely. They weren't just saying their product was good. They had the numbers to show it.
I bet that made a big difference for customers, like seeing the proof.
Huge difference. Especially these days, people want more than just marketing slogans. They want to see the data, understand how things work.
So it's not enough to just say, hey, trust us, this product is great. You got to show people why.
Exactly. And that's what this company did so well. They were transparent, they showed their work, and they let the data speak for itself.
I love that. Letting the science do the talking. This whole deep dive has been so interesting. It's really made me think about how much science is actually behind those little things we strap to our shoes.
Right. It's easy to just take them for granted, but there's a lot going on there.
Totally. But this also makes me think, like, what other everyday products could benefit from this kind of hardcore testing?
Ooh, that's a great question.
Like, is this the future of how we evaluate products? Could we see this with everything? Our shoes, bike helmets. I mean, the possibilities are endless.
Definitely. And I think it makes sense as consumers, we're getting more and more savvy, asking more questions, wanting more data.
Like, we don't just want to hear, hey, this is the best. We want to know why. We want the proof.
Exactly. And I think that's a good thing.
It definitely is. So, listeners, the next time you're out shopping for, well, anything really, think about the science behind it. Ask those questions, and don't be afraid to dig a little deeper.
You never know what you might discover.
Exactly. And that's a wrap on this deep dive.